electrostatics, Newton's laws, all of the above.
Okay, no, that's good. Okay, so let's go back to where we left off. This is where we left off. Let me first save it. And how was maths?
Maths is okay.
Okay, no, that's good. And are the marks already out?
No, they're gonna be out next time, sir. Right now we're on holiday, so.
Is it? Yo.
Oh, sir, you didn't know.
No, I did. Some people were telling me that the schools are closing next week, so I didn't know.
I closed last week, Thursday.
Oh, okay. And when are they opening?
On the 8th of April.
Okay, no problems. I'm trying to save this lesson. Okay, lesson 9. Sharp. You still remember the definition of power?
So is it not the amount of energy transferred or converted? Ish, something like that.
Power is the rate of work done.
Okay.
Yes, power is the rate of work done. So it is W over change in T. Okay. So last week we successfully calculated the resistance of resistor R. Was it difficult?
So it was confusing sometimes.
Is it?
Yes.
Okay, no problem. But do you understand the concept of the potential difference across the parallel connection?
Yes.
Okay, so V between 0.1 and 2 is equals to V across 0.3 and 4. They're always gonna trick you with that, so you must always have it in mind.
So are you presenting?
Yes, can you see the screen?
No, I can't see anything.
Damn. Okay, let me stop the share and then share again. Okay, can you see now?
No.
No. Okay. Let me see where the problem is. Okay, let me do this. Let me change and try to share this one. I just want to see. Can you see this one?
So maybe it's me. Let me see if I can rejoin.
Okay, no problems.
Okay.
Okay, let's see. Can you see? Ronel, can you see what is on the screen? Can you see now?
But I still can't. Oh, okay, now I see.
Okay, no, good. From what we did previously is that the potential difference across point 1 and 2 is the same as the potential difference across point 3 and 4. And also across, okay, if that's 4, let me say this is 5 and that is 6. And also potential difference across 1 and 2 is equals to potential difference across 3 and 4, same as the potential difference across 5 and 6. You said you understand that concept, right?
Yes, sir.
Okay. And what is the resistance? What is the formula of calculating the resistance or on a parallel connection?
Isn't it RT is equals to 1 over R1 plus 1 over R2
Can you
plus 1
repeat
over
that? Can you repeat that formula?
RT
Okay.
or
Let
1?
me write it. Okay. You are saying RT is equals to,
Is it? Oh, I'm busy confusing.
okay.
Is it 1 over R1 plus 1 over R2
Yes,
plus
that's perfect. Plus 1 over R3 if there was.
yes.
Yes, I was just confused here because you said RT, but it's fine.
No, I
Now,
meant 1 over.
okay. Okay, that's good. Do you understand that the total supply of voltage from the battery, it is going to be divided among all the resistors in the circuit? Do you understand that one?
Yeah.
Okay, and that means the voltage used by all the resistors, if you add all of them, you will get the total supply. I think you understand that.
Yes.
Okay, and you also understand that the current at A, when it gets to this point, it is going to be divided into two portions.
So can you repeat that?
The current that is flowing through A, when it gets to this point, it is going, some of the current is going into this branch and some of it will go into this one.
Okay, yeah.
Right? So if you have a total of 10 amperes going through A, how much will go into this branch?
If you have what total?
You have a total of 10 amperes.
So would we potentially have 5 going into the first branch?
Yes, 5. Okay, that's correct. And then when we get to this point, what will be the current that is going through this portion of a conductor?
Will it not be the sum of the current that has gone through the 2 branches?
Yes, which is 5. Then back to 10.
10.
That's correct. So the 10 is essentially the total current of the circuit. Do you agree?
Yes.
Okay, perfect. So the other thing that you must bear in mind is that in your exams, they will use two strategies to trick you. Whenever you see an unknown resistor, or if you see an unknown resistor which is not in your parallel connection, or if you have an internal resistor, because usually an internal resistor, they give it as an unknown. Usually when you have such a situation, they want you to use all the parameters given within the circuit. Or usually they want you to use all the parameters given within your parallel connections, usually. So that's why, given that we have an unknown resistance, I didn't bother starting by doing the calculation with the 15 volts because I have an unknown resistance. So I just went straight to my 12 ohms. Given that I have 1 ohm of current going through it, it means I have two parameters already. And for Ohm's law, you need three parameters, which is V, R, and I. In this case, we had R and I. So if we have the two, it means we can calculate the other. Okay, no, that's fine. So let's go to the questions now. The resistor R of an unknown resistance is now removed from the circuit. How will this change in the circuit affect the reading of ammeter A? How will it affect the reading of ammeter A? Ronel.
So I want to say it won't change.
Okay, why?
So because does the current not stay the same throughout the whole circuit regardless of the resistance?
No. If you change the total resistance of the entire circuit, it means your current will also change. If the total voltage supplied by the battery remains constant. That is according to Ohm's law. Ohm's law says, let me write it down properly. That is 4.3. 4.3. According to Ohm's law, the current is given by the total current is given by the total voltage divided by the total resistance. Let me ask you this quick question. In this case, does our V total change?
No, sir.
No, it doesn't. Perfect. Does our R total change in this case?
Yes, sir.
Does our R total decrease or increase?
It decreases.
The R total decreases. So if the R total decreases, what happens to our I total?
It increases.
it increases. If you want to see it, let us assume that we have removed resistor R. So if we have removed resistor R, you remember from our last session last week that the effective resistance of the parallel connection was 6 ohms. You agree?
Yes, sir.
Okay, so do you agree that the new circuit will be as follows? So we have A, and here the effective resistance is actually 6 ohms. And now that we have removed R, we have this case. So if we have this case, we know that our I will be given by, our I total will be given by the total voltage, which is how much? The total voltage will be, the total voltage, this is the total supply. We only have one resistor. It means all the supply, the voltage supply is going to go to this resistor. Do you agree?
Yes, sir.
So the total voltage will be 15, and the resistance, the total resistance will be, the total resistance of the circuit is how much?
6 ohms.
6. Okay, so 15 divided by 6?
2.5.
2.5. Is it an increase or a decrease?
It's an increase.
Because our initial current was
1. What? No. Yeah, 2.
it was 2. It was 1. You remember?
Yes.
Okay, perfect. 4.4. The power rating on an electric stove is 1,500 watts. If the stove is used for 3 hours and 30 minutes, calculate how much it will cost to use the stove. One unit of electricity will cost 1 rand, 1 rand, 15 cents. Okay, we are given this question. Where do we start, Romeo? Okay, we can go to the, yes.
So would we have to start by converting the time into okay, hours, and then I was gonna say we put it into the formula for energy, and then we say the cost would equal the energy times the cost per kilowatts. Was it kilowatts?
Yeah, it's kilowatt hour.
Hour.
Yes, kilowatt hour.
Okay, so I was gonna say if the power is one point, I'm gonna say 1.5, and I say 1.5 multiplied by 3 3 3.5.
Let me write it down. Okay, you are saying
I'm I'm using, I remember, sir, there was a formula: energy is equals to power times time.
power times time. Okay,
Yeah.
yes, yes.
And then the power they gave it to us, it's 1.5.
The power they gave us is 1.5.
1.5 multiplied by the time, which is 3.5. Yes, 3.5 hours. And
And,
that's,
and this is 1.5 kilowatts, right?
yes,
Okay.
yes,
Times, you said the time is
3.5.
3 3.5 hours, yes.
Gonna
So
give
this
us
mhm,
5.25 kilowatts hour 25.
5.25 kilowatt times hour
Okay, then
used.
then
Yes.
we have to go to how much they said one unit of, okay, so they said 1 kilowatt um hour costs 1.15. So would we say um 5.25, which is the energy, multiplied by 1.15,
So we're gonna have 1.15.
multiplied by the energy we calculated,
Mm-hmm.
and that's gonna give us 6.04 rand.
6.04
Randi.
rands. Yes, I agree with you. That's about it. So within 3 hours 30 minutes, this appliance will use 6 rand and 4 cents. I agree with your calculations. I agree with your calculations. Do you have any questions?
No.
Okay, let me find another question. Okay, let's try to find another question. Okay. Okay, maybe we'll have something here. Okay. I have nothing on this one. Okay. So normally, do you study during closure?
I try my best to.
Okay. Have you done any electricity problem?
Um. Ah. None that I have problems with.
Or you haven't had any? Okay. Okay, let's see. Grade 11, physics, June exams. Okay. Let's see. Okay. Take this one. Okay. Ish, I don't like easy stuff. Okay.
But I like them.
Do you like easy stuff? Okay, let's do some easy stuff then. But it will be a mixture of something which will give you some bit of difficulty also. And it will also be simple, but let's see. Okay. Do you watch TV that much? Let me say so. Do you watch TV that much?
Not really, so I'm always on my phone or a laptop.
Oh, you are one of those TikTok generations.
Ah, sir.
Yeah, there's nothing to be ashamed of.
Ah, sir. Every now and then, when there's something nice to watch, I'll watch on TV.
On TV.
Yes.
Oh,
In general, I'm always on my phone.
yo. Okay, I know. Um. Also, you only watch Mubang,
Hey, so I haven't watched Muvhango in a long time.
except for that day. There was a day when you wanted to watch Mubang almost.
Yeah, it was 9 o'clock. It was time.
Oh, okay.
But
Eh,
now it's getting a bit difficult now because we don't have that old DSTV anymore. So like I have to go through websites or I have to register for DSTV digital on the smart TVs. Yeah.
you are streaming now.
Yeah.
Okay. But what happens when the Wi-Fi is down?
Then everything is down. Then we start crying, sir. 'Cause then life is over.
Yeah, I see. Because I have a decoder as well.
Oh, that's our deco.
Yeah.
I don't know where our decoder is.
Oh, you
Uh,
misplaced it.
We used to have one, but then like we purchased the extra TVs and we've moved things around. So like, and all the TVs are smart. So you know, everyone was
Yes.
just busy with Netflix.
Oh, damn. Okay. Okay. Netflix and Showmax.
Yes.
Okay. Okay, no, that's nice. Okay, let's see. What do you want the youngins?
Oh, I started it. I started it. I had started it. I don't know. I'm still somewhere in season one. Somewhere there.
Okay, yeah, you must take it slow because there's books also. So yeah. Serious.
Oh
Okay.
God. Alrighty.
Okay, let's go to it. Okay. The circuit below consists of 6 and 15 ohm resistor connected in parallel and an unknown resistor. This is coming from a June paper. Yeah, I think last year.
Oh, okay.
Yes. And then they're saying an ammeter, a high resistance voltmeter, a closed switch, and the battery are connected as shown. Okay. The resistance of the battery and the wire can be ignored. Okay. The total power dissipated in the parallel part of the circuit is 50 watts. Define power.
The rate at which work is done.
Okay, 10.1.1. Power is the rate work done. Perfect. Okay, 10.1.2. Calculate the effective resistance of the parallel connection.
Okay, so we know the formula is 1 over RT is equals to 1 over R1 plus 1 over R2 plus etc. So so can I see the diagram? Okay, so it would be 1 over 6 plus 1 over 15.
Which is going to be, let's see, how much?
That's gonna be 30 over 7.
Okay.
7 over 30, and then like you swap it around.
It's going to be 30 over 7 or 7 over 30.
It's okay. The answer to 1 over 6 plus 1 over 15 is 7 over 30. But then because RT 1 is over RT, we're gonna have to swap it around, and it's gonna be 30 over 7, which is gonna be how many decimal places do you want it?
I want only one. For a resistor, only one. Give me one.
Okay, so that's gonna be 4.3
4.3 and the units?
ohms.
Yes. Okay. And then, okay, do you remember our steps of calculating the circuit? The first one is calculating the effective resistance.
So these are the steps
For calculating the circuit problems, for calculations of the circuit problems. Effective resistance of parallel connection.
And then if we had series connections, we would calculate those next.
If we had a series circuit, it means step 1 is gone. Then we go to step 2. So step
No, but
2.
what if it was like the time? Like
What if
it would. What if it was like the last example we did where it was um let's say two resistors were connected in the one branch, and then or two resistors were connected in the one branch, and then the other two were connected in the second branch. So does it mean that we would have started with calculating the series before the parallel?
Okay. What is the difference between the devil and Lucifer?
They're the same thing.
Okay. So if I divide 15 and give you, say, 10 and then another one 5 there, isn't that 15 ohms?
Yes, sir.
Okay. So are we going to apply step 1 either way?
Yes, but like if they were separated, would you not add them together as if they were in their own series connection?
No, we can.
Okay, but for now we're just saying step one is the parallel.
Yes, because we'll treat this. If we had 2 resistors in series here, we're going to add them and treat them as one.
Okay.
Oh, I remember. Yeah, now I remember why you're saying that. I remember because your answer was incorrect when you were resolving the parallel connection on the last problem we had.
Hey, hey. Oh, okay, but like it makes sense the way
Okay.
you explain.
Yes, if you have 2 different resistors inside a parallel connection, you might as well just add them. It's the devil or Lucifer. It's the same thing. Just
Okay.
that, yes, you can change the form, but we don't care. The second step will be to reconstruct the circuit. And the third is to calculate totals. V total, R total, and I total using Ohm's law. These are the only steps. Okay, let's see. Oh, do you have any question?
No, sir.
Okay, you will see how relevant these steps are. We have already calculated the effective resistance of the parallel combination. Now they want us to calculate the potential difference across the resistors in parallel. So how do we
Okay.
go about this one?
Um, do we not bring the formula V is equals to, is it R?
Okay, so saying calculate the potential difference. Okay, you are saying which formula should we use?
So am I correct to assume that voltage is the same as potential difference?
It is correct.
Okay, so would we not use the formula for voltage, which is V is equals to I times R?
Let me write down what you want me to write. That is 10.1.3.
So you
No,
must write down the right things.
okay. No, I will correct you later. You are saying I should write?
I said V is equals to I times R.
Okay, I times R. Okay. Do we have the value of I?
Um, yes,
Which is how much?
which is 10, 10 watts.
10 watts is the current.
Ah, that. Okay. Stand. So does I not stand for current, Mara?
Yes, I stands for current, but
So you see what you're doing.
do you see?
See physics, ne?
Yeah.
Ish. Okay, explain it to me, sir.
Okay. We are given the value of power, right?
Okay.
So why don't you think along the lines of finding the formula for power? The formula for power that
Is
can, yes.
okay, the formula for power is V times I.
Okay, formula number one, let me crush whatever you've done. Power is given by V times I, yes.
And we are given the power, which is 50,
50, yes.
is equals to, we're looking for V, so V multiplied by,
Do you have the value of I? Possibly not.
yeah, so
Do you have it? Do you have the value of I?
it's, okay, the current below,
You don't have.
so I don't see it.
You don't have, but do you have the value of R, if I may?
I would assume so, sir, because they gave us the the different values for the resistance. Or
Okay, okay. Why? Okay, if you replace I with V over R, I don't know if you agree with this one.
yeah, okay, I
According
see
to
it.
Ohm's law, do you agree?
Yes.
Okay, we will have V squared over R.
Uh,
So
okay.
50 equals V squared over R. Do we have the value of R? What is the value of R? Let's go to the question. Calculate the potential difference across the resistors in parallel.
Okay. So can I see the diagram?
And the steps also. The second step says we must reconstruct.
Great.
This is what we have. We have R, that's R.
Okay.
We also have, okay, that's A, fine. And then our new or effective resistance will be, we
Calculate
calculated, it was
4.3.
4.3.
Yeah.
4.3 ohms. So this will help you a lot because now you have a simplified circuit which is connected in series. And what they're asking is, they said the power dissipated by the parallel part is 50. So the R that you are going to use is which one?
Is it 4.3?
Exactly. We will have V squared over 4,3. So V squared is equals to 50 times 4,3. I don't know if you agree.
Yes, I do.
Okay, so 50 times 4,3 will give you
215, and then we'd have to square root it.
215.
Yes.
Okay.
And then we automatically square root it to get rid of
Which
the square, and that's gonna give us, is it still 1 decimal? Oh,
yeah, for potential difference, yes. Give me 1 decimal.
14.7.
14.7 volts.
Yes.
Okay. Let's see. And then they're saying calculate the current through resistor R. What will be the current going through resistor R?
Um.
What will be the current going through resistor R?
Okay. So we calculated the. So okay, I have a question before I answer. Does the
Yeah.
resistance we calculated, like, did we say that it equals to R? Like 4.3 would be equal to.
4.3.
Yes.
You said it is equal to R. This one.
Would it be equal?
This R.
Yes.
No. We have two resistors. We have resistor R. We also have the effective resistance, which
Oh.
we sum it up into one resistor and then we reconstruct. This
Oh.
is our
Okay.
new circuit.
Okay.
Yes.
Um.
Yes. Yes. So calculate the current through resistor R.
Okay. So current is equals to.
Current is equals to, I think you are heading to the right direction. I can smell it. 21. Yeah, for real. Okay.
So
I equals
yeah, I is equals to V over R.
which is
The voltage is 14.7 over R is unknown, is it not?
okay. R is unknown. Okay, no, I'm very happy. Okay, so if it's unknown, then what?
Um, mm, yes, I don't know where to go from here.
Okay, let me correct you. Question 10.1.3, they said calculate the potential difference across resistors in parallel. You agree?
Yes.
So whatever we got on 10.1.3, it is the potential difference across the parallel connection. This one.
Yes.
So if we know the potential difference across this resistor, and we have the resistor, can't we get the current?
Wait, so please repeat that, sorry.
Because from Ohm's law, you have three parameters, right?
Yes.
You have your resistance, your voltage, and your I. Here we have 14.7 volts across a 4.3 ohm resistor. We have two parameters already, which is R 4.3 and V, which is 14.7.
Okay.
And we calculate the current that is flowing through the 4.3 ohm.
Oh, oh, yeah, so we can.
Okay. So your resistance is actually 4.3. You are heading to the right direction, but okay. Okay, so 14.7 divided by 4.3, what are we getting? I think
14.7 divided by 4.3. So 3.4.
3.4. The unit is amperes.
So would I be correct if instead of um instead of using the I is equals to V divided by R, what if I used P is equals to V times I, and I just like manipulated the formula, so like I
You
would
said
equal
P equals V.
P equals V times I.
You are gonna get the answer right, and that's for sure. I guarantee you that. But let's see. There's so many ways to kill a cat. So many. There's another method, but okay. V was 14.7 times
Yes,
I. Okay.
yes,
So your I will be 50 divided by 14.7. How much
yeah.
did you get?
Yes, I got 3.4.
3.4. Perfect. There's another, there's so many methods. You see, the other method we can use, ne? You can calculate the current flowing through the 6 and the current flowing through the 15. You can say, or the current flowing through the 6, the 5 will be, sorry, the 6 ohm will be 14.7 times not times, it will be 14.7 divided by, because it's the voltage divided by newtons. Let me write it properly so that you see. Okay, it's fine. It will be V over R, okay, which is our V was 14.7 divided by the resistance is 6. This will give you what?
Yes. 2.5.
2.5. And then the
Oh,
other
so
one,
then let me say 2.45 because I'm
2.4.
scared I'm rounding up and stuff
Oh, too early.
before we
Okay,
get our answer.
no problem. Then
Okay.
I for 15 will give you again 14.7 divided by the resistance is 15. How much did you get?
0.98.
0.98. Okay, so I total is given by I6 plus I15. Do you understand this method now?
Yes.
Okay,
Yes.
so we're gonna have 2.45. Or do you have any question?
No, sorry, I don't.
Okay, so how much do we get?
3.4.
3.4. See, there's so many ways to solve these problems. Okay. Okay, so I just wanna Eish. Why is it doing this to me, man? Okay, sure. I just want to add another page. Okay. Yeah. Okay, the next question says, the switch in the circuit is now open. How will the reading on voltmeter V be influenced? Choose increase, decrease, or remain the same.
So will it increase?
It's saying it will increase.
Yeah, so I'm just
Guessing.
yes.
Okay. No problems. Okay. Either way, ne? If you remove, if you open the switch, right?
Okay.
Your effective resistance will now be 6. Do you agree? Because this resistor will have no potential difference whatsoever because the switch is now open.
Okay. Yeah.
You agree?
Yes.
Okay. The question is, did the resistance increased or decrease? The resistance of the parallel connection, did it increase or decrease?
The
Did it increase or decrease after the
so
switch?
it
Hmm?
it increased.
It did increase from 4.3 to 6.
Yes.
From 4.3 to 6. So if the resistance increased, right, will the portion of a battery supply increase or decrease on this parallel connection?
So please repeat your question.
Will the portion of the voltage of the battery supply increase or decrease on the parallel connection?
So on
Are we going to supply more voltage or less voltage given that the resistance has increased?
will supply more voltage.
We will supply more voltage. So if we are supplying more voltage, are we now going to supply, is the voltage V going to increase or decrease?
Will increase.
This one.
Which one? So will it not increase?
Remember, the total supply of voltage will remain constant, ne? You agree?
Yes.
But the supply of voltage that we had initially here, you said it will increase.
Yes.
Okay, let me give you this example. Okay, do you have a younger sister?
Yes, sir.
Okay, let's say your parents give you guys in total, say let's say 20 rand. You get 15, she gets 5.
Okay.
And then now your parents decides that no man, we want to increase the amount that you are getting, but the total is still the same. Ne? It means the amount of money you are going to get will be more. Am I right or am I wrong?
Yeah, correct.
Okay, and the amount that your younger sister will be getting?
Less. Or
Okay.
yeah.
Do you not get it?
I get it now, sir.
Yes, this is your younger sister, this is you.
Oh, okay.
Yes. So the reading on V will decrease. It will decrease. Explain your answer. To explain your answer in 10.1.6. 10.1.6 is that the effective resistance will increase. Therefore, more voltage supplied to the 6 ohm resistor. Okay, let's see the next one. A geyser labeled 200 watts is used for an average of 5 hours per day. I know you're going to ace this one.
So,
Yes, I know you excel. Okay. So they said the cost of electricity is 80 cents per kilowatt hour. Okay, fine. Calculate the energy used by the geyser for 5 hours per day.
okay, so energy is equals to power times time. So uh the power they gave us, we'll say it's 2 uh multiplied by the 5 hours, which is gonna give us 10 kilowatts uh, per hour.
10 kilowatt. What? Per hour?
No, 10 kilowatt hour per day.
Okay. Okay. Per day, sharp. And then uh we have the costs.
Okay, calculate the cost of electricity. So what was the question?
The
Oh,
question
the calculate the cost of electricity to operate the. Okay, so
but I don't think they said calculate the energy used by the geyser,
yes,
which you said it is
10.
okay kilowatt hour.
Yes.
Okay, let's mm, okay. I get this is the energy this is the power consumption. This is a consumption of power. Remember, power equals, it is the rate of,
The rate of work.
yes. So work done is given by, oh, okay. No, I see where you, okay. Yes. Yeah, no, it's correct. Correct. Perfect. Correct. Correct.
Okay.
Yes. Work equals power times T. Yes. So that's the energy we're talking about. No problems. You can use joules or you can use those units. It's fine. Okay, now let's go to 10.2.2. It
Oh,
says, what is the cost of electricity to operate the geyser for the month?
okay. Uh,
Within 30 days.
so
2 marks.
is it 2 marks?
Yeah. The mark says it all.
Okay, so would it not be the amount that we use every day, like per day, which is 10 kilowatt hours, um,
Okay.
multiplied by how many days they gave us, which is like 30 days for a month,
Yeah.
and we'll just multiply all of that by the cost of 1 kilowatt hour, which is 80 cents. So like
Is it?
0.8.
Wait. Okay, let's see. You're
Okay,
saying we're going to multiply?
the energy per day or the work
Yes.
per day, which is
Yes.
10 kilowatt hours. That multiplied by the number of days they gave us, which is 30 days because they said a month, and
Yes.
multiplied by the cost of 1 kilowatt hour.
Mhm.
I think they said it was 80 cents.
Yes. So we're gonna have
So
times 80
zero
cents is actually that
zero
amount.
yeah. So is it gonna be 240 rand
Okay. 240 rand per month.
per month?
Yeah, that's correct. So top one, I'm just gonna remove it. So the cost is equals to that. Yeah, I think we're done. I've noticed that you're very good with electricity consumption calculations. I'm the
Yeah.
one that pays electricity at home.
So, uh, I enjoy them. I enjoy this type of things.
Okay. I like the fact that you have grasped a lot. And I think we did a lot actually today. We did a lot and we did a lot of concepts that I am glad that you now understand. Okay. Before I let you go, I just want to ask you this quick question. What are the what are the steps of calculating the circuits of calculating the circuits?
Okay, so you said the first step was to um calculate parallel resistance,
Mhm.
and then you reconstruct your circuit, and then
Yes.
you calculate your total voltage, resistance, and current.
Yes. Using Ohm's law.
Yes, using Ohm's law.
Yeah. And yeah, that's about it. It's just that on this question, they were trying to trick you using power. You noticed?
Yeah.
Yes. So that means you must be careful with that one. You must be careful with that one. But the principle is the same. We're still gonna do a few more problems on electricity because electricity problems are tricky. They need you to think and a lot. Are you still there?
Yes, sir.
Okay, so yeah, we're gonna do few more electricity problems, and then we're gonna do what's remaining from electricity. They said you are going to which chapter? Is it gonna be chemistry?
It, I actually don't know.
Okay, but I'm gonna check. I'm gonna check. How good were you in chemistry?
It's the last year chemistry was nice in the beginning. The beginning where we were balancing equations and stuff, that was okay. And then I remember the last topic was stoichiometry. No, no, thank you.
For me, that was the easiest when I was doing grade.
Sir. Ah,
Serious.
uh.
Because stoichiometry is actually ratios.
It is, but like, hi,
Calculating the number of moles.
hi, and then you have
You
to remember like the percentage, what, and the.
oh, okay, I remember. Okay, I know what you're talking about. Yo. Oh, okay. Yo. Okay. And now I'm gonna make it easy for you guys. Very,
Okay,
very easy. Yeah, it's gonna look very easy.
okay.
Yeah, but did you get more on chemistry or in physics?
I think I've learned to enjoy the physics part more.
Oh, okay. Yeah, I've noticed everyone is enjoying physics more than.
Chemistry, I thought it was just gonna be mixing chemicals and balancing equations. It brought other things. We don't want that anymore. We're gonna
Yeah.
do waves and velocity and these things that we're doing now.
This is more easier than chemistry.
It's easier to grasp, I feel.
Oh, yes, yes, yes. But I feel with chemistry, you just need more practice. Those things are easy.
Yeah. Okay.
Yeah, you're gonna need more practice. And are you also aware that um, you're gonna need your grade 11 marks to apply for varsity?
So I've been hearing it everywhere.
Is it?
I've been hearing it everywhere.
Yeah, so that's why most of the times I I give more efforts to the grade 11s.
Mm.
I usually overlap the times
Yeah,
because
no.
yeah because I know it's gonna be a bit harsh for you guys this year. This year it's the year where you have to work very hard.
Mm.
Yeah, you have to work very hard because you said you wanted to study at UCT, right?
It was looking I according to my current APS score, I qualified to study at UCT. So it's an option.
Yes. Okay, UCT or VETS
Yes.
or UP.
Yes, all of them, sir.
All of them. Okay, the big ones. Okay. And you wanted to study what?
Dermatology.
Oh, a okay, the study of the skin
Yes.
diseases. Okay. Okay. Do you know what my advice is? Ne?
Okay.
Okay. Where did you check? Where did you check that you qualify to go to those universities to do what you said you want to do?
So I calculated my APS score
Mhm.
against the VITS, um, the VITS whatnots. Like, so I got a recent, I'm gonna say, formula for how you calculate according to VITS standards. So it told me like, okay, for English, if you got this percent, you add this, and if you got this, you add this for LO. And so I added up all the points I've earned so far, and then
Yeah.
I got my total APS.
Or the totals you got, did you add also your grade 10?
Yes, it was based on my grade 10. I,
Oh,
I
okay.
calculated my APS based on my grade 10, and then I pulled out all the different degrees under the University of Victoria, under WITS, under UP, yeah, the big ones. Under,
Okay.
and then I highlighted the ones I qualify for.
Yes, okay, that's true. Ne? Do you know what I would like to advise you?
Okay, so
What I would like to advise you is that even if you have done all your calculations and you still qualify, ne?
mm,
Yeah, I advise you to work even harder
mm,
because last year there were 800 800,000 matriculants that wrote the exams.
mm,
Out of that 800, I think 600 and something thousand passed because the pass rate was about 87, if I'm not mistaken.
mm.
So imagine that number. Which institutions is going to absorb such a number?
Yeah, none.
So do you see the competition?
Yeah, it's hectic, so I know.
Yes, even if you are meeting the minimum requirements, they will check how many students are competing for the amount of seats in the lecture, and then they will take the highest.
Mm.
Yes, that's the unfortunate part that we are having right now.
Yeah, okay, so I get you.
Hmm. So you have to yeah, pull your socks, especially in maths and science. Those ones, if you get more marks on those two, um automatically they will give you a first preference. First
Yeah,
preference, yeah.
I think that's the only reason why I'm doing physics, really. I don't think I'm gonna need it unless I decide to branch into engineering, which I might do.
Yeah, yeah, you're actually right, uh but the university's point system or the scoring system, it's weird sometimes because I think they want physics in medicine, don't they?
Yeah, some of them do. Some of them do require.
Yeah, even if you won't use it.
Yeah. So
Yeah,
I
which is crazy
have
for
to do
me.
it regardless.
Yes, yes. So hey, it's tough, but I like your choice also. Do you know why?
Why, sir?
Because a lot of students apply for general medicine because that's what crossed their minds most of the times when they think about medicine.
Mm.
Yeah, they apply for general medicine. But if you apply for a specialty in medicine, you stand a better chance.
Yeah, okay.
You stand a better chance because if you go to the rurals, not not a lot of people know what is it,
Dermatology.
dermatology is. They don't know. All they know is I want to become a doctor. That's it.
Mm.
And then they'll go and apply for general medicine. So general medicine will be flooded. But if you're
Eh,
specializing, you stand a better chance.
oh yeah, that makes sense. But
Yes.
um,
Mm.
do I don't you like only get to choose your specialties after like a couple of years of general medical training, like overall? I
It,
think
de- it depends on the institution because UCT offers which specialties do they offer? I know they have occupational therapy, OT. They also have physiotherapy.
mm,
Um, you have seen it, right?
yes, I have some.
Um, I'm not sure if they do. I think I'll check again because I'm not well vested with medicine courses. But I think some institution allow for specialization in your first years.
I think I'll have to search it up. I'd have to read
Yes.
because when I was checking
Mm-hmm.
the it was the only two ones that were kind of related to where I want to go was medical, the biomedical field, which I don't want to go into. I don't want to do biomedicine, and um medicine, just medicine. So I think for most of the universities you study for maybe 4 or 5 years, and then you get to pick like, okay, I'm gonna specialize in this.
Yes. Okay. Um, I was checking also. Okay. Yeah. Okay. Yeah. I'm seeing here in America you can specialize. At UCT, I think you do general medicine.
Mm. And
Yeah, I
you see,
think
it's just medicine.
it's medicine. Yeah. Okay. Um, Let me see. Universities offering programs needed to become a specialist in dermatologist in South Africa. UP, VETS, uh, UKZN, Medunsa, University of Free State, University of Limpopo.
Mm.
Yes, but I don't know if there's such thing as studying dermatology starting from first year.
You, I,
But
I hope we find somewhere because
yeah,
that would. But I mean, also, I don't know because a part of me wants to get over with the general medical part of it. Like, if universities say I have to do general medicine for 4 or 5 years, I think it would benefit me if I decide um I need income as soon as possible, or whatever, then I could just become a general practitioner, a GP,
Then you
and then I
specialize
could,
late.
yes, and then I'll study on the side for dermatology whilst I'm still getting a GP income. I'll be
Oh
working at
yes.
dermatology income.
Yeah. Yeah. No, medicine is a good field.
Yeah.
It is a very good field, and there's money. Yo, there's money there.
So,
Uh, Trust me, there's money there.
and skincare is expensive.
Exactly.
Mm.
Oh, you wanna okay. Oh,
Ah,
you
I'm,
wanna
I'm,
treat celebrities now.
ah, I treat everyone. I treat everyone. I
What
treat,
can you buy? What can you buy?
hey. So those are the ones that give us money. Don't laugh.
Do you think she has money? That one.
Hey, so you don't know. Her songs are the real stuff.
Okay, okay. Let me let me agree to disagree.
Mm.
Yeah, but but yeah, it's a very good field, medicine. The thing is, with me, I didn't like I didn't like operating people, man.
So I also don't. I think I'm just planning on thugging it out for those 4 5 years where I
Mm.
have to dissect frogs and do what and yo. I think the reason why I decided dermatology is because I want to stay on the surface. I'm not digging into anyone's heart or anyone's brain or anything like that. We're just dealing with the surface, the things we can see outside. I'm fine with that.
But with plastic surgery, you're gonna have to do a surgery.
But I can also choose if I decide to work in some sort of business where they're dermatologists of like different specialties, like there's this person who does plastic surgery or this person who does whatever. I do prescriptions and whatnot. Then so be it. But I think I can handle myself. I trust myself. I, maybe I might not like that part, but I believe I can do it.
Yeah, the thing is, you just need to tell yourself that I will be able to do one, two, three. Then you go
Mm.
do it. Yeah, then you go do it. It's not
And
that hard. Yeah.
over time, I'll get used to it. I think, yeah, over time, it will be normal for me now, and then
Yes.
I won't have a problem.
Yes. And eventually, you must also try to get a mentor. Eh?
Mm.
Yes,
I've,
if it's
I've,
possible.
yeah, I have my own dermatologist. The one I used to go to. I still go to her. I have her, and then so you see, when you're thinking smart, you make connections wherever you go.
Exactly.
If I'm going to the dentist, I asked him, I'm like, hey, do you have any dermatologist friends? And he's like, yeah, I can hook you up when it's time. So I have my connections. I just need to make maths and physics work right now.
Exactly. So it's very important. Yeah, I like how you move because it means you're already done. If you have a connection, you are done already with school because
Hey,
he or she isn't a she.
yeah.
Yeah, she will take you through all the steps
Mm.
that she went through, and it's going to be easy for you.
Yeah, I would just hope
Yes,
for the day. I give everything to God. Grade 11,
exactly,
not gonna be easy.
exactly, exactly. So just make sure you you ace your maths and your science, and the rest is history.
Yeah, literally.
The rest is history. Yeah. Do you picture yourself at varsity?
Sir, I'm not against it. I'm
No,
really not. I'm
no,
not.
no, no. Do you sit down and think how the situation would be when you get there?
Yes, sir. Like, in terms of, I've thought about, um, like, if I were to move out the house and, like,
Yeah.
live at res or in my own
Yes.
apartment, and how I'd
Yes.
handle things and manage my life alone. Yeah, I've thought about it, if that's what you mean.
Yes. And trust me, that life is nice. Uni- trust me, the university, I don't regret. That life is nice.
Yeah.
That life is nice because you get to have your own freedom. You get to learn independence. If you're at UCT on weekends, you would go to 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 places.
Mm,
Yeah, more waterfront, Century City,
mm.
and ice skating sometimes.
Yeah, I'm excited. I feel like I've prepared. My parents prepared me well. Like if they want to throw me out the house now, I think I would float.
Yeah, that's good. That's a good one. That's good. And yeah, so you're just left with, well, just 1 year. I don't count this one. You're left with 1 year.
Yeah.
University, and that's it. And that's it. Okay. So good luck with your studies, and study hard, and especially maths and science. If there's any question, do not hesitate to ask. And whatever task we send to you guys, I urge that you write them, because they will be containing something that's going to help you in the exams.
Mm.
Yeah, I will send you guys tasks. Say maybe where next week when you guys open.
Oh, okay.
Yeah.
Okay,
Okay.
so
All right. Have a nice day and enjoy Mubango. All right.
okay, bye, sir.
Bye bye.